Hi, I'm Trustin. Nice to meet you all, and thanks for coming to my session. I'm usually known as a founder of the Netty project, but in this session, I'm going to introduce my new project called Armeria, a microservice framework. At the end of this session, you will know what Armeria is and why you have to choose Armeria over other frameworks when you build your service. And also there's a Twitter handle there. So if you have any questions or feedback, just let us know by mentioning us. So let's get started. What is Armeria? As written in this slide, it's a user-friendly Java microservice framework based on a synchronous and reactive model with HTTP2 and modern RPC protocols in mind. There are many important keywords in this single sentence, so we're going to focus on each of them one by one. First of all, it is an asynchronous framework. Why is a synchronous programming model important in microservice? Let's just start from a very typical synchronous microservice, which receives a bunch of requests from the client and accesses many shards of backends for the client. We usually split the backends into many shards so that data accesses are distributed evenly and nicely. Based on the request, the service will determine which request should go to which shard. In this diagram, a green request goes to a green shard, a blue request goes to the blue shard, and so on. And there are a bunch of worker threads here. They drain the pending request from a task queue and performs the actual data access. Pretty typical, and everything's good. Every shards are responding quickly, no problem at all. However, let's say one of the shards start to fail, responding very late, like taking 10 seconds or something more like that. And how often will this kind of failure happen in large-scale system? It's every day. Because of the failure, thread 2 will take much longer than usual to handle the request for shard 2 in this diagram. At the beginning, this doesn't seem to be a big deal because all other threads are handling the request for other shards as well, very well. So in this case, shard 1 and 3 are fully functional, so everything seems okay, just a tiny bit of problem. But the reality is, even if shard 1 and 3 are responding quickly, it is only a matter of time for most threads to get busy handling the request for shard 2 because it takes majority of time, so without giving a room for handling other requests. Unless shard 2 is recovered really quickly, the worker threads are dominated by shard 2 and other shards will be affected, regardless of whether they are capable of handling the request or not. So what does all this mean? It means just a partial breakage can trigger the entire service to go down. It's a problem. So how could we solve this problem? How about adding more CPUs? If you look into the metrics of the systems offering this kind of problem, and they are actually not very busy in terms of CPU. They are actually just waiting for the backends to respond. So they are busy waiting. How about adding more threads to the thread pool? It might save some time, but it's not a good idea either. No matter how many threads you add, they will get busy like any other threads in no time. Of course, there are some workarounds like splitting the thread pool into multiple sections. For example, some thread pool A could handle the request for shard 1, and the thread pool 2 could handle for the request type 2, something like that. But The fact is you have to keep tuning it whenever the situation changes. For example, when the number of shards changes or your backend configuration changes, you have to reconfigure your application, and you want to avoid that, right? So now we know why a synchronous programming model is important, but it's not the only piece we need to build a robust microservice. It has to be reactive. Armeria implements Reactive Streams API, which is a de facto standard for building, for streaming data reactively in JVM ecosystem. Have you ever heard of libraries like RxJava, Project Reactor, or Spring Webflux? They all implement this API, so we are interoperable with them very easily. But why do we need to be reactive? Why does it matter? It's because it helps your service not blow up with out-of-memory error under load or handling a large amount of data. It can easily happen when building an asynchronous system. Let's say we have to send 10 megabytes of personalized responses to each of 100,000 clients at the same time. You cannot deduplicate it. Of course, you cannot hold them in RAM at once because it's 1 terabytes in total. So we have to stream it chunk by chunk, bit by bit. If we stream the data, we have to be very cautious about the speed of data production. For example, if we send it too fast, the client will not catch up. The data will be buffered on our side, and then we will get out-of-memory error again. Reactive Streams solves this problem very nicely, and that's why we chose it. So asynchronous and reactive. Modern RPC. Many microservice frameworks, including Armeria, is based on HTTP, as you know, but it doesn't mean it supports only RESTful services. There are various compelling alternatives to REST in microservices architecture, and one of them is the RPC protocols like gRPC, Thrift. At Line, the company I work for, we use Thrift extensively with Armeria for communication between microservices. Also, Slack, the chat-based collaboration service company, uses Armeria for gRPC calls. Why is Armeria special for gRPC? Let's find out. This is a simple example of a usual RPC call over HTTP, which has failed at business logic level. On the left, it's a request. On the right side, it's a response. So if you look into the response, even if the request has failed, HTTP status is 200 OK, which means success. Ironically, it is pretty common for RPC protocols to use 200 OK always and put the actual result into response body. HTTP-based frameworks often do not provide the information like method name, parameter values, and parameter names, and return value or exception of the RPC calls. And they are hidden under the cover. I call this problem an impedance mismatch between RPC and HTTP. How about access logs? This is a fairly common access log file example. If you look into the access log file written by an application server, you see the same impedance mismatch. You barely get what you want. What if we provide access logs with the universal API for gRPC, Thrift, and REST, and provide RPC level information like parameter names, method names, parameter values, return values, and also with precise send-receive network timings, all programmatically, not using access log files. Let's imagine you stream this information into your data processing pipeline using Kafka for further analysis or event generation, like alarming on a certain error. It would be pretty cool, right? Another long-standing issue of RPC is that it is often hard to make an ad hoc call, like sending an RPC request without any IDE setup. So far, we had to first find a proper service definition file, such as .thrift file or .proto file, and set up the development environment, like build the tool and IDE, and write some code that makes an actual RPC call. It takes energy, and it's pretty messy. In contrast, for HTTP, you can just use a tool like curl or even telnet command. There has been some efforts for RPCs, but its history is pretty short and it does not cover all RPC protocols. So we made something more convenient and even collaborative in Armeria. I'm going to show you soon. Also, as far as I know, Armeria is currently the only framework that allows you to run both gRPC and Thrift services at the same time in a single JVM. And let you serve both so in a single HTTP port and in a single JVM. Of course, without using any proxy servers like HA proxy, Envoy, Linkerd, etc. It's actually not just gRPC and Thrift. You can even serve non-RPC requests like RESTful API, static files, even Prometheus metrics, and also it can serve health check requests from load balancers. You can even serve the traditional Java EE web applications, which is based on Tomcat or Jetty as well. All without opening an extra TCP IP port, without launching 2 or more JVMs, just in a single JVM. So imagine imagine you have both gRPC and RESTful endpoint for the same business logic. You can share a lot of common business logic and only write some additional code that's different from each other for gRPC and RESTful API. So you can share a lot. And so Armeria can simplify your service configuration because you don't have to run any additional proxy servers, or you don't have to launch additional JVMs, or you don't have to open an additional TCP IP port. And the migration between different service types is very easy because you can launch legacy Tomcat application and your new gRPC service in the same virtual machine and gradually migrate from Tomcat to gRPC and then remove Tomcat. It's very easy. And this is the last part of what Armeria is, user-friendliness. Did you have a poor experience when using a certain library? Well, we can't name it. But what library do you have in mind, and why were you unhappy with it? Even if it does its job, if it's complicated or very undocumented, or it has its own weird issues, then it will make you unhappy, right? That's why we focused on user experience. When we say UX, user experience, it's often about front-end applications, but it is not actually. UX is not only important for end users, but also very important for ourselves, the developers. Nobody wants to use a framework that's hard to use or unintuitive, especially when there are plenty of choices in the market. You know, there are many microservices framework in Java world, right? So one of the goals when we designed Armeria was to do our best to give our users a better experience when they build an asynchronous service, such as user-friendly API, smooth learning curve. So did we succeed to deliver feature-rich yet user-friendly library? Well, let's find out real soon. So our answer is Armeria. So we visited the every element that makes what Armeria is. It is the result of our effort to build a user-friendly, gRPC-aware, asynchronous, and reactive microservice framework. We built it on top of Netty to provide the best asynchronous programming experience and performance. We built it on it implements Reactive Streams API, and it is interoperable with other Reactive Streams implementations, such as RxJava, Project Reactor, Spring Webflux, you name it. It also lets you mix and match different service types using a single server. And also, it's not just HTTP2, it supports HTTP1, of course. And what's interesting is you can even serve gRPC services on top of HTTP1, which was previously not possible. And also it supports other protocols than HTTP1 and 2, like HA proxy. So if you are working with HA proxy, you can connect with HA proxy using the protocol that is understood by HA proxy, which is pretty nice, because you don't have to parse headers like X4 did 4. And of course, we really try to make it easier to use. Now we know what Armeria is. Let me show you some examples. Let's start with simple HTTP API examples. In this slide, this is a hello world example, which is very, very simple. We start with a builder pattern by creating a server builder class, and we specify port numbers like HTTP on 88, HTTPS on 8443, pretty typical. And because we are serving an HTTPS request, we have to specify some TLS certificates, as you know, but because it's pretty cumbersome to generate a self-signed certificate or something similar, so we provide a very simple builder method called the TLS self-sign, so you don't have to care much about it. It just auto-generates everything. And here's HA proxy protocol support. And what's interesting here is that you specify the same port with HTTP on 8080. So in this case, we do protocol auto detection based on the input of the network input. Armeria will determine if the protocol is HTTP or HA proxy protocol, and then it will automatically switch the protocol, which is pretty interesting, and it can be very handy when you do not want to open multiple ports due to some technical or political issues. And now we bind a service, a hello world service. We use slash, which means a root path, and there's a lambda expression. We accept context and request, and we transform it into a response. Creating a response is pretty simple in this case. So we use a factory method in a class HTTP response. So HTTP response.of and then message. This will generate a plain text response with 200 OK status code. Pretty simple, right? And then we build a server finally. We get this will give you a RESTful API server, which supports only GET request. Now we can start the server, and that's all. You started a hello world server. Very simple. But in reality, you need to accept some sort of parameters. Like using some path patterns or path parameters or query parameters, you know. So in this case, we get the path parameter by using context.pathPattern method. And when you bind the service, you specify a path pattern. So here the path pattern is /hello/:name. :name is path parameter. So if somebody sends a request to /hello/Armeria, the parameter name will have the value Armeria. And we use %string to format the response. Pretty simple, and yeah, that's the service that accepts one path parameter. However, in some cases, people might not be happy with this kind of programmatic approach, but prefer some declarative approach, which is similar to other web frameworks. We support that as well. In that case, we use a method called Annotated service. This Annotated service accepts an arbitrary object, which is annotated with the annotations we provide. So in this case, we used @get annotation with the path parameter, and then Armeria will inject the parameter in path variable into a path parameter when invoking the hello method. And in this case, a string is returned, and then string will be converted into the HTTP response object we are constructing in previous slides. But this is not all, of course, because Armeria is asynchronous and reactive. It allows you to return a completable feature or reactive streams. You can return whatever you want. And also it supports what other web framework supports, like query parameters and cookies, and you can also define some custom request and response converters so that you can return your business logic objects very easily. And we also provide JSON-based JSON conversion out of the box, so in most cases you don't have to do that. And there are also exception handlers, and we also support content type negotiation, regular expression-based path mapping, which is way more advanced than the path patterns we saw previously. The point is that we want to be better or on par with the web framework you are using, or on par or better than the web framework you're using. So if you have if you happen to use Armeria and you find something that's missing in Armeria, you could just tell us, then we're gonna be more than happy to fixing that by adding features. So far, I showed very simple HTTP examples, and this time I'm going to show you RPC examples, which is also actually very simple. So as I said in previous slide, Armeria supports Thrift and gRPC. Are you all familiar with RPC frameworks? I mean RPC libraries like Thrift and gRPC? Tried it before? When you write an RPC service, it's basically a three-step process. First process is write an IDL file, which looks like the code here. So on the left side, it's a Thrift IDL, and on the right side, it's a gRPC IDL. What it does is pretty much the same. So it receives a name and returns a string which contains a message. So we are going to write a hello service using Thrift and gRPC. And once you write an IDL file, .proto or .thrift file, it has to be compiled into a .java file. Once it's compiled, it generates some interface classes or abstract classes, so you can fill its stuff. Then it will be turned into an actual service. So let's start from gRPC. Like a usual Armeria server, you start with a server builder. But in this case, you do not specify an HTTP-based service, but in this case, we use gRPC service. So we create a builder called gRPC service builder, and we add service called myHelloService, which is an implementation of a gRPC service. And below the slide, there's a class myHelloService, which extends the class, the abstract class generated by gRPC protocol buffer compiler, and it has one abstract method, hello. So we implement it. We first prepare a reply object and send it using the callback object given as a parameter. Pretty typical, right? So in this case, our Armeria server is not a RESTful API server, but a gRPC server. So it can handle both, but you can choose what you want to do with it. Very flexible. And for Thrift, it's pretty much the same. So in this case, we created a service called THTTP service, which means Thrift HTTP service. And below, there's myHelloService class, which is an implementation of HelloService.async face, which means asynchronous interface, because we are building an asynchronous Thrift service. Although we do not stop you from using synchronous version, but going asynchronous is the whole point of Armeria. So here's an abstract method called hello, and there are some parameters and callbacks like we saw in the gRPC example, and we prepare a response message and call the callback. In this case, this is not a gRPC server. This is a Thrift server. So Armeria can handle HTTP gRPC, Thrift, right? But you might have some question about this. Why do we have to do this? Because there is also an official gRPC server implementation, and there's also an official Thrift server implementation. Why should we do that? Why should we use Armeria? Because we have more features you will need in production. For example, for gRPC, it works both on HTTP 1 and 2. In an ideal world, HTTP 2 support is just enough, but in real world, you have to support many cases where, in some cases, your load balancer might not support HTTP 2 very well, or there are some issues with it, so you have to fall back to HTTP 1, things like that. And there's also gRPC web support. This allows you to call gRPC services from JavaScript, which means your web browsers, so that you don't have to choose different protocols between when communicating with front ends. So from front end to back ends, it can be all gRPC if you choose to do so. And for Thrift, Thrift is being continuously developed, but its HTTP 2 support is pretty much nothing before Armeria. But now Armeria supports HTTP 2 when using Thrift. That's a killer feature for our customers. And also we support a new serialization format called ttext, which allows a Thrift request to be represented as a RESTful, REST-like, REST-ish JSON object, which means when you're in short of time and you want to provide some easy-to-use API for your clients and they don't want to use Thrift, you can use t-text to serialization format so that they can send a JSON object to the server and respond in JSON object, which is pretty nice. And also, you can mix and match all these different kind of services. For example, gRPC, Thrift, and REST, and even Tomcat and Jetty applications you have built before. This means you can, migrate smoothly when you have, or you don't have to make your code more complicated when you have to support more than one type of service type. Like your customer wants, for example, some customer wants to send a gRPC, and some other customer wants to use Thrift. Some other customers prefer REST. In that case, it can be consolidated very easily. And also, it allows you to leverage very rich features provided by Armeria, like decorators and web-based consoles. I'm gonna show you soon. So, decorating services. So, have you ever heard of a filter, decorator, interceptor, or middleware when building web application? It's a very common term, like Servlet filters. Armeria has that too. So in this example, we intercept an HTTP request. So there's an HTTP service, but we call .decorate method with it. And we pass a decorator. And then if a request comes in, the decorator will be evaluated first, and then we'll go to the HTTP service. In this example, we log request and response, which is pretty typical when you want to know what's going on. But in this example, we can't access RPC-based information just yet because it's an HTTP service. As the name HTTP service says, it's an HTTP service. So in this case, you need to decompose HTTP service into two pieces. One part is Thrift call service, which is an RPC layer service, and another is HTTP service. It's an HTTP layer service. So when you split it into two, you get the whole information. So we created Thrift call service and then decorated it. And in the decorator, we now have more information, like RPC method name, RPC parameter names, and return values, what exceptions were raised to after the call is finished. So we have complete access to the RPC call information, and you can even override the parameters in the decorator, and you can even change the method name and change the return value or raise an exception when a client sent a wrong parameter. You can do everything. Decorator is not limited to a simple use case, but also useful for many cases. And actually, Armeria implements many common features using Decorator. For example, request throttling and metric collection using Micrometer API, and also using Zipkin-based distributed tracing and content negotiation, authentication and authorization, CORS, circuit breakers, automatic retries, everything related with building our microservices. For example, Zipkin distributed tracing is done using Decorator too. In this case, we use HTTP tracing service, which is a decorator, and we specify some parameters. Then your service will send Zipkin spans to Zipkin span collecting servers automatically at sampling rate of 5% in this case. In production, you might want to add more decorators. For example, logging and whatever. And in the beginning of this session, I talked about sending an ad hoc request, RPC request is pretty hard in RPC protocols. We solved that by introducing a service called the documentation service. And the Armeria documentation service is an ordinary Armeria service. So you add it to server builder when building a server. And once it's added, it allows you to browse and invoke RPC services running in an Armeria server. So there's no need to play with binary payloads because it's all converted from and to JSON. And also you don't have to write any code to send a request. It has a web form that lets you to send a request. It supports gRPC, Thrift, and annotated HTTP services. Eventually, we want to make it more like a dashboard for administration by adding some metric monitoring console and allowing you to adjust some runtime configurations like log levels. It looks like this. It looks like Java doc. So there's a list of services on the left side, and there's the specification of a certain operation on the right side. So there are parameter names and the types of the parameter and what's the return type is, what exceptions can it raise. And what's interesting is you can also send a real call. So here's a text area on the left side. You specify some JSON object so that you can specify key value of the parameter. And then if you press the submit button, the request is really sent to the server, and then you get the response in JSON. So you don't have to look into the binary protocol stuff. Simple and easy. And what's interesting is that if you look into the URL location area, you see the request body is encoded into the URL, the location. So if you copy and paste the location to your colleague by sending an instant messaging, for example, he can click the link and reproduce the request very easily. So there's no need to tell him how to reproduce the bug. You can just copy and paste the URL, and then he can reproduce it very easily. So all pieces together, we can build something really huge, really awfully huge. Yeah, we can add some Thrift service, add some gRPC service in the same server, and sometimes you have to serve some static files. Like, for example, when you build React front-end application, you have to serve static files as well. And because you have some legacy service, you specify some Tomcat service as well. You can even launch two or more Tomcat service instances. And of course, you want to add doc services. And if you are working with load balancers, you can add health check service to respond to it automatically. And then because Armeria allows you to record metrics, you can expose the metrics to Prometheus scrapers so that your server metrics are easily accessible. And in the last line, there's a method called access log writer. It allows you to send access log to somewhere. For example, in this example, you sent it to Kafka for further processing. For the client side, it's pretty much the same. It has common types, HTTP request and response and decorators, and it is RPC friendly. But there are some client-side specific stuff as well. For example, circuit breakers, automatic retries, client-side load balancing, retrofit integration. So here's a simple yet full example. So when you are using Kubernetes, you discover your services using DNS queries. See, in this case, we define DNS service endpoint group under the domain name of myservice.cluster.local. And then you register it with weighted round-robin straightedge and register the endpoint with the name myservice. And then when you create an HTTP client, you specify a URL, and in the host name section, you specify group and group name. In this case, group : myservice. If you create a client like this, whenever you send a request, the request to using this client object, it is automatically distributed to the services discovered by DNS service endpoint group on the top. So client-side load balancing is very easily achievable. So does all these features make you feel interested about this? If you're interested, we can build this project together. It's an open source project, so please give it a try, and if you have any questions, please ask questions. We are more than happy to answer them. And if there are any missing features for building your service, just let us know. And if you are happy with it or unhappy with it, just let us know so we can fix it, or if we can make it even better. And if you are really interested, you could also write some code with us. We have a very strong and friendly community, so just fire up a pull request and we are happy to review. So let's meet us at GitHub. And please don't forget to follow our Twitter account and also star our GitHub repository. And I have some stickers for this project, so if you're interested, just let me know. And this is a QR code of the Git repository, so please feel free to take a picture of it and visit it later at your convenience. Thank you.
Thank you very much, Trustin. A very interesting talk. There are a few questions for you. So let's go for the first one. It says, please, how will you compare Armeria to Quarkus?
Quarkus is actually Quarkus is comparing to Armeria. Armeria is does not try to implement everything comparing to Quarkus. For example, Armeria focuses on implementing providing things that are required to build a server or client which is related with networking. So, for example, Quarkus or other frameworks like Micronaut, Spring Boot, they all provide its own dependency injection, its own database access layer, but Armeria doesn't do that. Armeria focuses on providing a way to build service only. So if you want to integrate with other frameworks like Spring Boot or, for example, Spring Boot, it does not interfere with you. For example, if you want to use a Spring Boot framework, but if you want to also play with Quarkus, they can't live with each other because they try to compete with each other, and they have their own dependency injection framework and other implementations. But Armeria doesn't try to do everything. It focuses on what it really does well, and it integrates very well with other frameworks like Spring Boot. For example, when you build your reactive application with Spring Boot reactive stack, you can replace reactive Netty with Armeria, which means you can serve gRPC services using Armeria, but you can build your Webflux applications using Spring Boot, and they can be mixed and matched together in a single JVM and single TCP/IP port. So they are fundamentally different in terms of philosophy.
Okay, second question here is, you commented something about curl, telnet. Does netcat differ here? So this is about netcat command. So
I think I see the question. So the question is, the question is about, can a tool like netcat? Yeah, it might be possible, but in reality, you don't really want to type your RPC request binary format using your keyboard, right? So I think it's not doable using netcat.
okay, thanks. So another question here, is there an open API auto-code generation support?
There's no open API integration at the moment. We are actually going to work on it. So if you're interested, then just let us know so that we can prioritize it better.
Thank you. And the other question, the final one, is there a Spring Boot starter for Armeria?
Yes, it has a Spring Boot integration, so you can integrate Armeria when using Spring MVC or Spring Webflux, or even without any Spring Web. So if you're using Spring Boot for just dependency injection and data access, you can use Armeria. And if you're using Tomcat as a web application layer, then you can also integrate with Armeria. And then in that case, Armeria will handle HTTP request and forward it to your web application. And for Webflux, it is pretty much the same. Armeria will handle the request and then forward it to your Webflux application.
Okay, Trustin, thank you very much. I wish you the best with your Armeria project. So, thank you very much.
Thank you.